All right, let's look at it from one triangle at a time. So I want to look at the triangle right here. I want you to go ahead and add 70 plus 54 and subtract it from what? 180, and give me what that other angle must be. And it's okay to do the tedious math on the side. Someone confirm. Is it 56? So I'm going to write 56 right here. So let's only worry about this triangle and list it from least to greatest. And I'm going to go from, let's see, are we going least to greatest? Yes. So 54 is the smallest, so that means side, what is the smallest? AD. And then 56 is our next one, so side what? AB. And my longest side just in that triangle is how many? Or which one? BD. And I will leave them alphabetically at all times because something is going to repeat. All right. So I'm going to get rid of what I have. You don't have to. I got rid of you. Thank you. Now let's focus on the middle triangle. Go ahead and add the two known sides or angle measurements. Subtract it from 180. Go. Someone confirm. Is it 70 on the unknown?
77.
77? Is that right?
Yes.
Okay, 77. So just by looking at that middle triangle, which side is my smallest?
BD.
BD. And then our next one is side BC. And our largest is what? DC. I'm going to say CD because something's going to repeat. And I'm going to mention something right now. Do you guys see that BD is the last one and BD is the first one? There's a reason behind it. Because if I were to cut them in a strip, they overlap. Let's see if that happens on the next one. All right? It needs to go bye-bye. Now let's look at this one right here. Add the two known angle measurements and subtract it from 180. 60? 60? Confirm? Okay, 60. So just by that, what side is my smallest?
DC.
So I'm going to say not DC, but alphabetically. CD. And the next one is? DE. And the last one is? CE. And let's see if something repeated. This CD repeat right on the other. So imagine three different strips, overlapped values kind of stick together, and we're going to write this in order. So here I go. So we know AD, AB, BD. So AD, AB, and BD. These two are repeated, so I'm not going to write it again. So I'm going to write the next one right here. BC and CD. Again, CD was repeated. I'm not going to write it anymore, but move on to DE and CE. So without repeating any of the redundant sides, we know AD is the smallest and CD is the largest side. As long as you look at them by one triangle at a time, something is going to repeat. So here's how we can self-check. If something does not repeat at the ends, can we say we made a mistake? Okay, most likely maybe you added wrong or subtracted from 180 wrong. Is everyone good on that? Something, again, will repeat, guarantee. Good? All right, now let's go on to our two proofs. Okay, on our two proofs, let's go ahead and write in what we know so far. Okay, Ian, what's the first given?
BX equals AW.
All right, so we have BX is equal to AW. And that's the reasoning for what? Given. Now, when something is equal to, I need to translate that to what? Congruent to, because I'm looking at pictures, correct? So I'm going to say BX with the segment above is now congruent to AW with the segment above. And that was by definition of what segment? Congruent. I forgot to put the right def. Congruent segment. Now I can notate. So let's go to our picture. We have AW is right here. BX is right here. What letters should I write to represent a side or an angle? S, very good. Okay. And a S, what's my second given? Wonderful. And don't forget the segment above it. And that reasoning is all what? Given. So let's notate. TA is right here. TB is right here. What letter am I going to write on that? Side as an S. Very good. So my final goal is to make TW and TX. So let's go ahead and highlight my two triangles. So we know for sure it is a small triangle on the left and small triangle on the right. And I want to look at the picture as a whole. This part I do not want you to highlight, but look at the board. I need all eyes on the board. If you look at this big triangle and ignore everything in the inside, do I have two sides that are congruent to make the opposite angles congruent? Can these two make these two angles congruent?
Yes.
Most definitely. So let me undo this. So let's notate on here. We know these two angles are congruent, and let's notate that it is angle. Do we see side angle side automatically?
Yes.
Okay? For this angle, because it's unique, you don't have to say TAW. You can simply say angle what? Angle A is congruent to angle B. And the order does matter. We talk about sides first and then the angle. So here's my abbreviated version. If two sides in a triangle, this is only in a triangle, so you must mention triangle, then we know the opposite angles are congruent. Congruent. And again, these got to match that I'm going to highlight. Sides, TAs are my sides. Angles, angle A is an angle. It has to be in that order. Everyone good? Okay, so I'm going to go back. And then I know the two triangles are now congruent by what? SAS. So Ian, go ahead and start off with the naming the triangle. How do you want to start?
TAW.
TAW. So John, if Ian went from TA to W, how would I make that consistent with the other triangle?
Oh,
If we went from T to A, oh no, that's the wrong A to W, we went this way, right? Go in that other reflected direction.
oh, TBX.
Good, TBX. And that's by side angle side. And then I could write our final goal. So our final goal is TW is congruent to TX. Let's see if y'all remember. When do we use CPCTC? After two triangles are congruent to, you may use CPCTC. If you forget the acronym, you can then spell out corresponding parts of congruent triangles are congruent. Is everyone good on that? Okay, if you're good, give me a thumbs up. You should feel like an expert on the proofs at this moment. Okay, our next one. Let's first analyze and see which two triangles we're looking for. So I think we're going to go ahead and notate on this one. Y'all ready? If OM is cutting PMN in half, we know PMN is here, so these two angles are congruent. So at this point, here's our argument. It could be these two small triangles, or it could be the big halves, right? So let's see how we can narrow that. Our next one, it says MN is congruent to MP. That's not very helpful, right? But look at our final goal. What am I trying to get to? Aren't I trying to get to these two right here? So am I looking at the two small one on the left or overall top and the bottom? Top and the bottom. Let's highlight it now. I'm going to highlight my top in one color, bottom with another. Do y'all see reflexive property of congruence on the MO? Oh, let's go ahead and notate it while we're at it. Is this side angle side also? Yep. All right, so when I call on you, give me the givens. Okay, Jackson, the first given is what?
OM bisects angle PMN.
Good. OM bisects angle PMN. And Jackson, what's the reasoning for that?
Get it?
Wonderful. And now I can say the angles are congruent. Now for the angles, I can't say angle M. I need to be very specific. So if I say angle NMO, Noah, can you give me the other angle? PMO. And keep in mind the reasoning matches diagonally. So this is not definition of segment bisector, but what? Definition of angle bisector. If you just say definition of bisector, you're not going to get credit for it, so be really careful. So let's highlight the two pieces that match. If I have bisect on the statement, the next reasoning on the second one must match. Are we good? Okay. And then the next one, Lily Blue, what's our second given?
MP
Yes, ma'am. And what's the reasoning on that one? Good. And we've already notated, so I'm not going to worry about it. What was the part that's being shared called? What property of congruence? Reflexive. So we have MO is congruent to MO. Now, we can't just say reflexive, but we have to say what other word? Property of congruence. Make sure you have all that. Now, can I say the triangles are congruent? Yep. Owen, will you name the top triangle? Would you say NMO? So, Josie, to be consistent with NMO, how would I make the other order? Wonderful. PMO. And what was our reasoning, everybody? Side angle side. And our final goal, Stephen, it says prove what? Wonderful. And again, when do we use CPCTC? After two triangles are congruent. So we have CPCTC. And done.